Hi children, good morning. Welcome back to our session. So in the yesterday's class we have learned about the potential difference. Is it? So today's our class is Ohm's law. What is that? It's the Ohm's law. Let me see the definition for the Ohm's law. German physicist George Siemens Ohm. George Siemens Ohm stated that electric current flowing through a metallic wire. What is that? Electric current flowing through a metallic wire is directly proportional to the potential difference across its ends. Electric current flowing through a metallic wire is directly proportional to the potential difference across its ends. Here, the temperature will be constant. That means provided its temperature remains the same. What's the temperature? What we are going to provide the temperature will be the same. So this is called as the Ohm's law. So how we can derive this Ohm's law? So here we have told that the electric current flowing through a metallic wire. Electric current is nothing but I. It is shown by the symbolically I. So electric current flowing through a metallic wire is directly proportional to its potential difference. So directly proportional to its potential difference is nothing but V. So I is directly proportional to the V. Here we want to take off the proportionality. That means when the current is increasing, its potential difference also will be increasing. So I is directly proportional to the V, or we can write V by I is equals to constant. What is that, children? V by I is equals to constant. So instead of this constant, we have to take one constant symbol. So we are going to take it as R. R is nothing but here. R is called as the resistance. R is called as the resistance. So what we can say for the Ohm's law, V is equals to IR. What is the formula we got it now? What is the formula we got it now? V is equals to IR. What do you mean by the R? R is called resistance. Then what do you mean by the resistance? The resistance, it is the property of a conductor to resist the flow of charges through it. So what is the resistance? Resistance is the property of a conductor. Property of a conductor to resist the flow of charges. To resist the flow of charges is called resistance. What do you mean by resistance, children? What do you mean by resistance? It's the property of a conductor to resist the flow of charges. It's nothing but resistance. Then, what is the SI unit of this resistance? The SI unit of resistance is nothing but Ohm. The symbolic, how we are going to write the Ohm? It's the Greek letter. So, in the Greek letter, we are going to show that symbol. That symbol, it shows the R. R is nothing but the resistance. That is the Greek letter. So, now, what do you mean by R, children? R is the resistance. So, R is equals to V by I. R is equals to V by I. Then, what do you mean by 1 ohm? Let me see now. What do you mean by 1 ohm? So, here itself we can say R means resistance. What are the units of resistance? It's the ohm. V means potential difference. What is the unit for the potential difference? It's volt. Then I is nothing but current. What are the units of the current? It's the ampere. Now what we are going to define? We are going to define it as 1 ohm. What do you mean by 1 ohm? So just you add it as 1, here as 1, here 1. This itself, it shows what do you mean by 1 ohm. Yes children, from here itself we can derive what do you mean by 1 ohm. So if the potential difference, so where we can find the potential difference? Across the two ends. The potential difference across the two ends of a conductor. The potential difference across the two ends of the conductor is 1 volt. The potential difference of two ends of a conductor is 1 volt. And what is this ampere? 1 current. And the current through it is 1 ampere. Then the resistance R of the conductor is nothing but 1 ohm. Let me see once again. What do you mean by 1 ohm? If the potential difference across the two ends of a conductor is 1 volt and the current through it is 1 ampere, then the resistance of R is nothing but R of a conductor is nothing but 1 ohm. So for this, let me see one activity for the Ohm's law. So in this activity, we need one ammeter and one resistance for one ammeter, one voltmeter and one nichrome wire. We have to take the 3 cells. What is that children? We want one voltmeter, ammeter, cells. How many cells? We are going to take it as the 3 cells and nichrome wire. Voltmeter, ammeter, 3 cells and nichrome wire we have to take. So let me see how to take this. So arrange the things. So this is the nichrome wire. For this we have to use the ammeter and a plug key. And the ends of this nichrome wire we have to give the connect of the voltmeter. So plus and minus we have taken here, and ammeter plus and minus, and voltmeter also we are going to take it as the plus and minus. So this is the arrangement of our circuit diagram. So now what we are going to do through this diagram, we have given the connection of the voltmeter, ends of this nichrome wire, X and Y. So this wire, it shows for us the resistance. When the current is flowing through this, we have to note the readings. So for readings also, let me take one tabular column. Let me take one. Let me see the tabular column, how to denote the readings in this activity. Now, let me tabulate the column. So, according to our Ohm's law, now we have taken the circuit diagram. Here, only one cell we have taken. Through the cell, when the current is passing, we can have the readings of voltmeter and as well as the ammeter reading. So, first number of shells. How many shells we have taken here, children? Only one. So, what are the readings of the current? We have to mention. So, reading of the current is nothing but I. Potential difference is V by I. How it is going to increase? Whether it is going to increase the same or different, whatever may be, we have to mention it. Then, we have to increase the shells here. Next, we are going to take it as next another shell. Once again, we have to note down the readings. In the second, we have given the connection of the two cells. Now, what is the reading in the voltmeter and what is the reading in the ammeter? We have to mention it. Then, we are going to increase the shells. Now, how many shells we have taken? 3 shells. Then, what about the current? And what about the potential difference? So, when we are going to increase the shells, what will happen, children? The brightness, that means the power, the current also will be increases. That's why the Ohm's law itself, it tells that the V is directly proportional to the I. When the V is increasing, potential difference is increasing as well as the power also will be increases. V is directly proportional to the I. So, V by I is equals to constant. V by I is equals to constant. So, how we can plot the graph by using of these values? That means here on the y-axis we have taken the potential difference and on the x-axis we have taken the current. So, our current also increasing in this manner. So, here the V is directly proportional to the I. So, this is the activity to explain about our Ohm's law. Yes, children, here is the activity related to the Ohm's law. So, with the Ohm's law, in simple words, tells us about the relationship between the potential difference and current. Current is equals to voltage by resistance. I is equal to V by R. I is directly proportional to V and inversely proportional to the R. If more potential difference, more current will flow. More resistance, less current will be flowing. So, you can see the circuit diagram. Now, for this we need the nichrome wire, voltmeter, ammeter and electric cells. So, this electric cells also we have to take 1 to 1.5 volts. Now, here we have taken only one cell. Nichrome wire for the resistance, voltmeter and also ammeter we are having. Plug key, yes, we can observe here the plug key also, children. So, here is the column. In this, let we note the points in this. So, in the first case, we have given the only one cell. The current it is passing through it is I1, V1. In the second case, if you have given the two cells, then the current is I2 and the potential difference will be the V2. The ampere itself, it is going to measure the current. The voltmeter measures the potential difference, that is I2 and V2. Now, here we have given the 3 shells. So, I3, V3. When the number of cells are increasing, the current also will be increases as well as the potential difference also will be increases. So, to note this, here is the another column that we have to note down the V by I. V is nothing but potential difference, I is the current. So, V by V1 by I1, V2 by I2, V3 by I3. So, these three also will be in the equal. So, we can say that the potential difference is directly proportional to the current. This was explained by the scientist called George Simon Ohm. V is directly proportional to the I. That means here we have to note down that the resistance will be the constant. What is that, children? V is directly proportional to the I. So, we can write V by I is equal to constant. That constant here, it is nothing but R. R is called as the resistance. What do you mean by R? R is called as resistance that resists the flow of charges. What is that? It resists the flow of charges. What are the SI units for the voltage? So, volt. For the current, ampere, and for the resistance also it's the ohm, and the symbolic representation, that's the Greek letter, we have to write like that. So, what is that? 1 volt. 1 ohm is equal to 1 volt by 1 ampere. Next, after the Ohm's law, we have seen what is the resistance and we have learned about what is 1 ohm. Next, let me learn about factors on which the resistance of a conductor depends. What is that? Factors on which the resistance of a conductor depends. Ohm's law. At constant temperature, the current flowing through a conductor is directly proportional to the potential difference at its end. Mathematical form of Ohm's law. V is equal to R into I. So, where V is potential difference, I is current, R is resistance. What do you mean by resistance? Resistance is defined as the ratio of the potential difference across the conductor to the current flowing through the conductor. Or resistance is the property of the conductor to resist the flow of electrons through it. So resistance R is equals to potential difference by current. R is equal to V by I. What is the cause of the resistance? When free electrons drift inside the conductor, they frequently collide with its positive ions or atoms. The motion of the electrons is opposed during these collisions. SI unit of resistance is ohm and it is denoted by the Greek letter. The symbol of the ohm is this. So what do you mean by 1 ohm? If the potential difference across the two ends of the conductor is 1 volt and the current through it is 1 ampere, then the resistance of the conductor is 1 ohm. 1 ohm is equal to 1 volt by 1 ampere. What is the relationship between the resistance and current? The current through a resistor is inversely proportional to its resistance. So here, why the tungsten filament is used almost exclusively for the filament of the electric lamps? Because the melting point and resistivity of the tungsten are very high. It does not burn readily at a high temperature. The electric lamps glow at very high temperatures. Hence, tungsten is mainly used as the heating element of electric bulb. Inside the bulb, we are seeing one filament, children. That itself, it indicates the metal, that is nothing but the tungsten. So what is the difference between the resistance and resistors? Resistance, the property by virtue of which the material opposes the flow of current through it, is called as the resistance. Then what do you mean by resistor? Any material which has some resistance is called as resistor. So let me see the activity. When the length of the wire is doubled, the ammeter reading decreases to half of its initial. So in the second point there, the wire which we have taken is doubled. In the first figure, the same length of the wire we have taken. Here the wire is nichrome wire. In the second case, when the wire is doubled, we are going to see the decrease to half of its initial value. When we use a thicker wire, in the third case we can see the thick line that indicates the thicker wire. When we use the thicker wire of the same material and the same length, the current in the circuit, it will be increases. Due to the thickness, we are going to see the increasing of the current. In the last case, we are going to take the different material, that is nothing but the copper. When we use copper wire of similar dimensions in place of nichrome wire, the current in the circuit increases. So in the first case, nichrome wire. Second case, we are going to increase the wire. In the third case, thickness of the wire. The material is same. So in the last case, the same length. Length is not going to change here, but the material is going to change. That is nothing but the copper. So what are the factors on which resistance of a conductor depends? The resistance of the conductor depends on its length, on its area of the cross section, on the nature of its material, temperature of the conductor. It's very important for your examination, children. Resistance of the conductor depends on the length. So resistance of the conductor is directly proportional to its length. R is directly proportional to the L. So resistance of the conductor is inversely proportional to its area of the cross section. So inversely means we are going to write it as R is inversely proportional to 1 by
A. Resistance also depends on the nature of the material. Which type of material we are going to take, that is very important. So, resistance also depends on the nature of the material of which the conductor is made. The resistance of copper wire is much less than that of a nichrome wire of same length and area of cross section. That is, R is inversely proportional to the area and directly proportional to the L. So, resistivity is defined as the resistance offered by a cube of material of side 1 meter when current flows perpendicularly to its opposite faces. So, in this case we have shown that R is directly proportional to length and inversely proportional to A. So, here we have to remove the proportionality and we have to take the constant. That constant is nothing but rho. That rho is our resistivity. Here we are having one of the symbol, that is nothing but the rho, RHO. We are going to write it as RHO and pronunciation is rho. Rho is equal to R into A by L. R is here resistivity. Resistivity into area of that material by length. So, what is the SI unit of this resistivity? Means ohm meter. Resistance is ohm. Resistivity is ohm meter. So, what is the difference between this resistance and resistivity? Electric resistance of a conductor changes with a change in the length or area of cross section of conductor. So, what do you mean by resistivity? Electrical resistivity of a conductor remains constant at a particular temperature. So, how we are going to classify the solids on the basis of resistivity? On the basis of resistivity, solids can be classified into conductors, insulators, semiconductors. Let we learn about this in the next class. So, by this, let we complete our session. Okay, children? Thank you.